Okay, I really appreciate everybody coming out tonight. Let me change the slides. Okay, so I'm going to, I have a house in Hawley with Marianne and I, and we have targeted to be a zero net energy house. Now, because we're a seasonal residence here in Hawley, we're there. We definitely are net zero or producing more than we're using. But the year we stayed over, the full year, and stayed through the winter, was not this past winter. We would not have been net zero this past winter. But the target for building this house was to be net zero. And we, 5 years into it, we've got a ways to go yet. But the person who helped me, or the people who helped me the most in doing that, were the architects of our house. And co-presenter tonight, Rob Lewis and his partner, Margaret Locker. So we're going to present to you, not just that example, in fact, very little from that example, because there are so many other better examples of home building and home building techniques to try to save energy and be a high-performance building, whether it's a new construction or a retrofit. And so just quickly to cover what we're going to do, I'm going to do a quick introduction.
If you shift a little bit,
okay.
There we go.
Gotta watch that. I'm going to do a quick terminology introduction and economics discussion. And then Rob's going to talk for the rest of the hour on all of the details of the building, foundation, walls, windows, roof, all the things that are important in building the house and designing it. And then I'll come back after the break and talk about some of the things that we've covered in other Seeds forums this year, but I'll summarize them all together and talk about heating and ventilation systems, domestic hot water systems, lighting, appliances, and all the other things that go into energy consumption in the home. And then we'll bring it all together with a quick review of a relatively basic whole house energy model. So you can actually put together for the whole year what your house or a house would consume in energy. And based on that, building on the forum from last month, you can then size a solar voltaic system or other generation system to generate the remaining energy you do use in your house. So that kind of summarizes the course there in this 2-hour discussion in very short order. But the whole idea is to get to zero. Now, not everybody can get to zero, and that's okay. A high-performance house is still a valuable house. But if you think of what a normal house is, and I'll use what we call a code-compliant house these days here, we're in Wayne County, we're actually in Zone 6, whereas Pike County is in Zone 5. So there's the little difference in the code-compliant insulation requirements. The walls are the same, it's an R20 wall, and we'll talk about whether that's a true R20 wall or not later. Rob's going to get to that. But the attic insulation in Zone 6 is actually supposed to be R49, and I think in R5 it's R38. So there is a little difference between Wayne and Pike County by code compliant. But you don't need a lot of insulation to get to R20 by that rule. And so that's what we're going to refer to a normal or standard house. That's what we're going to use. A high-performance house or building is better than that. And I'll just leave it general because we'll use that term a lot. A super-insulated house is focused on that insulating the envelope. And that's what I would call our home in Hawley, as a super-insulated home. It has some passive concepts in the sense that it's oriented and located, and we use a lot of passive daylighting. And we do get some solar gain through the windows, and Rob's going to talk more about that. But that's a different concept than what I would call a certified passive house, which is actually, there's a Passive House Institute of the US that originally took the concepts that were developed in Germany. So you might see it also spelled passive house in German. But they've now separated from the German parent and become a fully independent organization. And they have a very detailed process to help architects, designers, and homeowners and builders go through and build a certified passive house. And it's got a lot of modeling, a lot of detail modeling, a lot of components that you have to get, a lot of details from the manufacturers on their specs in order to comply with that certification. But if you ever do have a certified passive house, you can be certain that it may not be net zero, it may or may not be net zero, but it's going to have a very low energy load. So the other term we use a lot in this is energy. What do we mean by energy? Well, specifically, energy is measured in British thermal units, BTUs, or kilowatt hours. So we're going to use those terms a lot, and I'll define them somewhat later. But energy also has forms of source energy or site energy. So source energy is the energy that might be generated at its source. So if you think about burning coal to generate electricity at a power plant, it's actually the energy altogether that is embedded in the material when it's mined, the coal when it's mined out of the earth, and then transported to the generation plant and burned, and some energy is lost in that process of transporting it, processing it, burning it, and then if it's electricity that you're consuming, you lose yet more energy when it's transmitted from the generation plant to the power lines before it reaches your house. So altogether, our typical electric use in our home has 100% site energy somewhere back in the deep in the infrastructure supply chain. But by the time it gets to the house, on average, it's only 27% of what it was when it was dug out of the ground. Okay, so that's the difference between source energy and site energy. Now, the good news is if you're generating your own energy on your site, that's 100% site energy. So if you've got a solar PV system, or you're burning wood that you yourself harvested on your property, not bought wood pellets and imported them, that would be 100% site energy too. If you imported the wood pellets from the neighbor, that's very close to 100%. You probably have to discount the chainsaw oil and gasoline, but that's about it. Okay? So we're going to talk a little bit about site energy, and we're going to define what we mean by net zero energy. It's all the energy used on the site annually minus the energy you generate on the site. Okay? So that's netting out to zero is the target. And the loads you might see when you're using energy, obviously space heating is the largest load of any American home, or most of any American home anyway. But you also have cooling and ventilation requirements to go with that. Hot water is usually the second highest. And of course lighting appliances and plug loads. Those are the other things you use. And you can't count, you've got to count all your plug loads, like the tools in the garage or the workshop. That's loads on the energy load too, that you're using on the site, not just the hair dryer and the electronics. Now, you also get a lot of gains, and some of these gains are passive gains, and some of them are active gains. So when we say passive gains, that's things like solar energy coming through your glass windows and adding heat to your house in the winter. That's a good thing. Now, it's not so good this time of year, but you got to generate cooling, or you got to open the windows to get it cooled off. There's also on-site generation. So last month at the forums here at the seed sponsor, we talked about installing solar photovoltaic systems. And that's the easiest to talk about when we talk about net zero homes, because it generates electricity directly. And that's something we need and can use easily inside the home with very little losses. But that electricity could come from solar PV. It could also come from a wind turbine on your site. Some homes have a waterfall, or at least a rise or a pond dam, lake dam, that you could use some micro hydro generation. And there are other things like sustainable biofuels, harvesting your own firewood. But again, it needs to be done sustainably to count. So those are the things that we talk about when net zero energy. And being an engineer, when I think energy, I think of kilowatt hours or BTUs. But some innovative people have thought about this in other ways. What if I count net zero energy in dollars instead of units of energy? I know an elementary school in Kentucky that claims to be the first net zero elementary school anywhere in the country. And the way they calculated it, I didn't know until 2 years later when I happened to talk to the installer of their PV system. And he showed me their electric bills. And I said, there's no way this is net zero. And he said, well, it is because they're getting dollars back at a much higher rate from the utility. So they were net zero energy in units of dollars, not in energy of units of kilowatt hours. Another interesting way to count net zero is emissions. And for purposes of counting your carbon footprint, that could be a useful unit of energy to count. If you're using coal, that's going to have a lot more emissions than if you're using nuclear power or if you're using solar power or wind power. So that might be a an alternative way to count net zero energy if you really were focused on carbon footprint or pollution. So all of those are valid, but for the purpose of our discussion today, we're going to talk about counting it in kilowatt hours. So what are the design strategies for building that get you toward net zero energy, and or any kind of high performance building? The first one is really passive and active gains. So we'll talk about location and orientation, and Rob's going to talk about some of the details of that. The second one is the envelope of the building. And when we say envelope or shell, we're talking about the surface area of the building. So it's all the walls, the roof area, the foundation. It's that area that is the volume of your house, that surrounds the volume. So it's the perimeter of your house. And it can be confusing when we get into the modeling, because we start a square foot of shell or square foot of envelope. It's not the square footage of the building that you live in, but it's all the walls summed together, and the ceilings and the floors. And the key things there are, first is the size. A smaller house is going to use less electricity than a bigger house. If the house has lots of dormers and angles and add-ons and other components that make it up instead of being like a square salt box, then you're going to have more losses through those envelopes and a bigger envelope. So that's another way to save energy, is to design a simpler structure and a smaller structure. Then the losses of the space heating, cooling, ventilation, the hot water, including things like the well pump, if you're on that, or a septic pump as we have to dose the septic field, and all the other plug loads, lighting, and appliances. So, and key to remember is, as designers and engineers, we say, okay, we're designing this building to be net zero energy. But the quote from one of our instructors is, there are no net zero energy buildings. There are only net zero energy occupants. Because user behavior in the building will make a huge difference on the load. And the plug loads and the hot water usage, whether you use CFLs or LEDs, that can make a big difference in the energy consumption of the house. If you don't turn off the lights when you leave the room, all those things your mother taught you, or at least my mother taught me. And last, and only last, do we then talk about the generation to make up for the rest of the energy load. And of course, if you're doing a design for yourself, or you're an architect or an engineer or a builder, and you're doing it for a client, it's not just these four things that matter. It's also the aesthetics of the building, especially when you want to live in it, and all the things you need to do to live in it, and the budget. So you have to balance all of those things. So what's it cost to build a net zero energy home or a high performance home? First off, the thing to know is for most people, your home is your biggest investment. And it's an investment that pays you back. And by that, we really mean you can save money in operating costs by spending more money up front. Okay? If you spend a little more money to build super insulated walls, you're going to spend less money in the future to heat that house every year you live in it. So you might have to get a bigger mortgage to build the house to be high performance. But you're going to save money on the utility bills for every year you live on it. And therefore, actually, in the future years, those 30 years you're paying the mortgage, you might have well paid for that extra cost by the time the 30-year mortgage is paid off. And high-performance homes, by every study that I know of, are identified as being higher value when it comes to resale. So think about this as an investment. It's better to think about it over not just the first cost to build it or to buy it, but the cost over its whole life cycle. And there are non-financial benefits as well. That lower carbon footprint, lower emissions, lower pollution, not only outside where the utility's burning things, but also inside the house. So you don't need to burn fuel inside the house, and therefore you'll have a healthier environment for you. But overall, the best way we can estimate it is to build a net zero house or a high performance house might be zero extra cost, just do the right things with the budget you have, might be 15% higher cost. But it's not going to kill you. And in fact, Rob found a great example of a builder in Massachusetts who builds net zero energy homes on spec. As you can see, it's a salt box, so it's pretty square. It's not huge. It's only 1,800 square feet. But it's only $105 per square foot to build it. Now, some of that is benefiting from Massachusetts solar incentives because they have a lot better state incentives than we have in Pennsylvania. But maybe that'd be $150 to build it per square foot here in Pennsylvania. Okay, so it's very affordable if you do it right, and it pays back before your mortgage would do so. Okay, so that's the introduction section. Are there any questions on that high-level discussion at this point? Okay, Rob, you want to come up and bring your slides up?